A very warm welcome to everyone who's listening to this podcast that's coming to you from the University of Transdisciplinary Health Sciences and Technology here at Yelahanka in Bangalore. I'm speaking with Professor Gurmeet Singh, who is the Dean of Research at the university. We call it the TDU. Professor Gurmeet is a expert in food systems, among other things. He has a BTech degree in chemical engineering from Indian Institute of Technology, Delhi, IIT Delhi, and a PhD in chemical engineering from Penn State University. And he has spent many years in academia and in industry, including 20 years in Unilever. But I'm going to let him tell you more details about himself and his work here at TDU. My name is Leena Wadia. I'm a physicist by training, but I got very interested in education some 15 years ago. So I have worked a lot in the education space, and I'm serving as Dean of Education here at TDU. So my first question to you is that why don't you tell us a bit about your time at TDU, because you've been here a little longer than I have. So what brought you here and what is the kind of work that you are doing?
Yeah, hi. Thanks for inviting me for this chat on food, and why it's important, and also the journey, right, of my journey about food. So I had spent a lot of time, my early part of my career, 25 years, working in academics, partly teaching in the US and then IIT Delhi in the space of biotechnology, biochemical engineering, and 20 years in Unilever on beverages and doing discover kind of work, new ideas on beverages, tea, mostly tea, some coffee, some soy drinks, right? And so on. And what started interesting me was how food was at the center of many of the challenges that the world faces, right? The world faces, probably you could say, three big challenges, right, globally. One is our own health as a species, like the health of human beings, every individual. Largely because a lot of the morbidity, 70% of our diseases are somewhere connected to our food choices, right? Then the impact of food and food systems on the livelihoods of people, right? Which is in India, 60 to 65% of our population earns its livelihood from food, either growing it or cooking it for a livelihood, or delivering it, right, for a livelihood. And when we look at the environment's health, right, then again in India, about 60% of our habitable land is devoted to a food system, 90% of freshwater withdrawals to a food system, 20 to 30% of greenhouse gases, pretty much every species extinction in the world is ascribed to land use change on account of food. And therefore, this realization that food was at the center of plate, so to say, to address some of these global concerns was an exciting, right, was a motivating force to say, hey, let's study food, not just from how do I make this recipe at a larger scale of process, but how can food solve these big issues, right, globally. So that's what interested me, and I thought that this kind of work I could do, had more freedom to do, more freedom to explore if I came back into an academic setting. And so that was the motivation to come back to an academic setting. But then the question is, why TDU, right? And the TDU is a very unique ecosystem. No, this university has been researching, university and before it, the Foundation for Revitalization of Local Health Traditions. So nearly 30 years of work, it has been researching and documenting what we could say are local ecosystem resources and the associated knowledge with those local ecosystem resources for human health, for animal health, for planet health, right? For food formulations, etc. And so this kind of a knowledge, where in-depth knowledge, which is documented and therefore researchable, is not available, I think, anywhere else
Yes.
uh, in India and maybe even globally, right? At least for the Indian ecosystem resources, the botanicals and the other minerals, etc., which are used for health practices, dietary practices. Oh, did you had a database of, when I visited first, I was shown a database which had 6,500 medicinal plants, very well referenced and documented from 3,000 years of literature, right? And and the metadata along with that as to what benefits of these, what are the formulations, where are these plants found. That kind of resource is not available anywhere else, right? Plus, TDU had a very unique faculty, right? Where there were faculty who were like biologists, having studied in the best biology and biotechnology universities of the world. But equally, there were people who were very well versed with traditional knowledge, Sanskrit scholars, Ayurveda scholars, also people who had worked at the ground level in the field on outreach activities, right? And that kind of a mix of faculty, which was interacting with each other and not siloed into various departments, I felt I had not seen in many places. I had worked in multiple cities and multiple continents in the US, in Americas, in Europe, in India, in Delhi, right? And so I found this ecosystem was a very unique ecosystem, and it drew me to this ecosystem to see if there was a program which you could set up on food studies, or broader food studies. Yeah. And that's what drew me to this place. Yeah.
Thank you. Thank you for that wonderful answer. Before we proceed further, I thought we should probably tell our listeners a little bit more about the transdisciplinary nature of our university. So, can I invite you to tell them a bit about what is the transdisciplinary approach that we are taking, and um,
Yeah. So
elaborate a
yeah,
bit?
yeah. So I mean, this word transdisciplinary actually intrigued me when I first heard about it, right? I had heard the word trans first time uh, in growing up in Delhi. Uh, there were places across the Yamuna, they were called trans Yamuna colonies, right? So the word for me growing up as a kid was trans is across, right? Somewhere. The second exposure was in high school, and then 11th and 12th in chemistry, where you start learning organic molecules, and you have cis and trans configurations of molecules. And whenever functional groups are across a double bond, they are called trans. When they're on the same side of the double bond, they're called cis, right? So
Right.
give me some sense of where trans is, and both of them kind of showed that they are on the other side, right? So when this place was called Transdisciplinary University, I was intrigued as to what does trans mean here, right? And so I think each one of us here evolves its own, wrestles
Understand.
with this name and tries to develop one's own understanding of it. And for me, transdisciplinarity is about, it's a little different from intradisciplinarity and interdisciplinarity and multidisciplinarity. Trans is where you bring foundations to very thinking knowledge system, very different knowledge systems, and try and integrate them and synthesize them and build something new, right? Which has its now new rules, right? Which emerge out of it to put things together. And I think that kind of knowledge, which brings cultures together and different ways of thinking together, uh, uh, creates transdisciplinarity. It's a tongue twister, right? For me, right? So many aspects of it I found here. I mean, one was, of course, the simplistic that you could say, a Ayurveda sciences with modern nutritional sciences, right? That's a very interesting mix. They have very different foundational blocks. You have people who studied in different languages and coming together. I mentioned Sanskrit scholars and people like us who are science scholars, no, coming together and discussing problems. There are then the multifunctionality of as well. We have a hospital associated with a university. Now, where will you find a very few universities where a hospital is associated with a university, but also that the university faculty and students walk freely into the hospital and can chat with the doctors, right? There's time with the doctors to be able to chat and discuss problems. So those kind of engagements I felt were very unique, and that's what builds this whole culture of transdisciplinarity. Also, one final point I mentioned the word local ecosystem resources, right? As you mentioned in my introduction, I'm a chemical engineer, right? And so all my education in chemical engineering was about scaling up, right? And the idea is that the ultimate scale is there's only one big factory providing the solution for the whole world for 8 billion people, right? Local ecosystem resources, the complete other end of it, right? Which is that how can uh, many small mini processing units come together, looking at what is available in the ecosystem where they live, and can we find solutions to our problems from there, right? Rather than one raw material that I find in a particular continent, in a particular geography, and can I exploit that for the rest of the world, right? So this kind of thinking, which merges local with global, with small with big, with traditional knowledge with modernity, right? Those are the kind of synthesis which I think lead to transdisciplinarity. Yeah.
Thank you for that. Let's dive into food then. Let's dive further into food. I know that you run what is called a Food Futures program. So
Yeah.
give us some perspective on the Food Futures program, because I'd like to eventually come to the educational part of the Food Futures program, the courses you run. But let's begin with the a perspective on the Food Futures program.
Yeah. So the uh, as I said earlier, that food is central to has a disproportionately high impact on all three dimensions of health: our own health, society's health, and the planet's health. Right, a
Right.
disproportionately high impact, and therefore, if we really wish to address these three global health problems of our health and society's health and planet's health, then food has to be center of the plate, right?
Mhm.
And therefore, Food Futures program is about trying to address all these three dimensions of health with what we call as food first solutions, right?
Mhm.
So can we use food as the first solution to address these? Because unless we address food and food systems, we will be creating the hypothesis, we will be only creating piecemeal solutions, and they will not eventually lead to a embeddable long-term solution that will create problems of their own, right, as we go. So that was the starting point. And we called it Food Futures because we feel this is the future of food, right? And the Food Futures also, I mean, one statement I keep making is that one, food can solve all these emerging problems of climate change, of metabolic health, of living longer and living healthy, of providing livelihoods, etc. Right, for everyone. But at the same time, uh, the interesting part of food I feel today is that never have we known lesser about food than we know today, right? And that's not because the absolute knowledge on food has reduced. The absolute knowledge, of course, we know more and more about food, its composition, its rheology, its structuring, its effect on human biology. But the unknowns have increased, and they've increased dramatically, exponentially in the last 20 years, right? Food and its effect on our genome, right? The nutrigenetics, the nutrigenomics, on our epigenome, right? So food and epigenome interactions, food and interaction with our microbiome. I mean, 20 years ago, these were not areas. 2002, 2003 is when we finished reading our human genome for the first time, right? Microbiome started becoming a field largely popular only after that, right? When we applied those very tools to study what resided in our gut. And then the whole area of metabolomics, right? That it's not just a few vitamins and minerals, but there are 30,000 different molecules that we are ingesting in a meal. And what are those molecules? What do they do to us, right? It's the whole area of food metabolomics, food omics, which helps us understand these molecules and therefore understand food in a broader way. The whole area of wearables that is becoming popular now, so that we have second by second information on our body parameters, and the integration of food with these parameters is another exciting area. So all these areas coming together are opening up such new fields that I think anybody who's looking at cutting edge and exciting work, right? As I said, never has there been a more exciting time to work on food, right? Yeah.
That's a lovely explanation.
Yeah.
So let's talk a bit about your lab. And you have a very large team, and they're doing. Maybe we talk about a little bit of research first, and then
Hmm.
we'll come to the education part. Can you tell us a bit about some of the very interesting pieces, just some indicative pieces of research that your team is doing?
Yeah, so I think largely when we look at our research program, we said we want to address the big health challenges, right? The three dimensions of health: our own health, society's health, planet's health. And our starting point for us is local ecosystem resources, and how do we find contemporary solutions, right, to the contemporary problems. Now, to do this, we in our lab look at three thinkings, as we call it, right? One we call is the systems thinking for food, which is thinking which connects food with ecology, right? Its impact on environment, and so on, and the circularity, right, from growing to consumption, and the circularity. The second is design thinking, right, in food, which is about consumer need to consumer delight and the journey through that. So that's the food and consumer journey. Right? The third is the health thinking, right? Which is the interaction of food with human biology. It's a little different from just nutrition thinking, because nutrition thinking, you're largely thinking of what should be on my plate today. So many milligrams of iron, so many grams of protein, so many grams of essential amino acids, essential fatty acids, etc. Uh, Wellness and health thinking is about the choices for iron that I'm making on my plate today, what will they do to me 20 years from now? Right?
Mhm.
So that's the health thinking. So these three thinkings are at the core of our research, right? Uh, and to be able to do these kind of thinkings, we start with, where do we start? We started with building a food database, right? Uh, uh, what are the ingredients which are, and we said, let's look at what are the ingredients in Ayurvedic texts, right? 3,000 years of history. What kind of foods have you been eating? What kind of ingredients have you been eating? How have you been cooking them? What have we been pairing to create a menu, and how have we been creating diets from those menus, right? So we started researching these and the benefits listed, and also information on uh, who should be eating this. So that is matching food to body type, because that kind of information, the personalizing of nutrition is available, right, in this. So we created this large database, probably the biggest of its kind on Indian food in the world, right?
Mhm.
About 1,500 or so ingredients with a lot of metadata associated. And then out of researching these, no, जो कहते हैं कि अध्ययन करना, right, of this, the recipes and the, right, we started constructing uh, rules, no, understanding decision rules for food, right, right from recipes and processing onwards. And two programs emerged. One we called as the Indian Culinary Science and Personalized Nutrition Program, right? And the second we call as functional foods program, new product development and functional foods program. So those are two big research buckets that we have. That Indian culinary science is about how do we take food ingredients that we grow and convert them into wholesome and nutritious foods, right? And how can we do that at the kitchen level, but also equally at a large scale level, right? At an industry level. Then the personalizing part is how do we match body type with food type, right? And we have a number of tools and research that we're working on that. Then the functionalized foods part is about how do we create foods for certain specific needs, right? And there are five particular needs that we are addressing in our programs. One is iron deficiency anemia, largely about minerals. How can we improve the mineral absorption through foods in our body? Because while food chemistry shows that there is a lot of minerals in the food, uh, they're not necessarily in an absorbable form, right? And so therefore, that area of absorption of minerals, iron deficiency anemia, calcium osteoporosis, right? The second part is proteins, right? And protein sufficiency, because that's a big challenge again in the Indian context. Just like iron deficiency anemia, 50% of Indian population, protein sufficiency, another big unstated need. The third area is that of gut health, right? And how do we, that's just for healthy living, right? How do I make sure my gut is healthy, right? The fourth area is metabolic health, right? And with specific cardiovascular health and glycemic control, right? So healthy fats, healthy carbs, etc. Uh, and the fifth area is brain health, right? And we selected these areas because even before I joined, there were teams here working on brain health, working on type 2 diabetes, etc. And therefore, we already had as a university strengths and cutting edge biology laboratories in these areas. And therefore, it was easy to, when we created the food program, we said we should definitely, right, build connections with the existing strengths of the university. Yeah.
Mhm.
Yeah. So that's the research programs, therefore, that we try and look at what kind of the functional food. So the Indian culinary science, the personalization, and this the last part in there is I mean, we define our program in terms of, you could say, healthy. We define in three blocks: uh, healthy gardens, healthy kitchens, healthy lives,
Mhm.
right? Healthy lives is about, I mentioned, the dimensions of health and what I need to eat, right? That's the personalization part. Healthy kitchens is the Indian culinary science. How do I transform food ingredients into healthy dishes, right? And that's very critical. Uh, and I'll come to that later again. And then the healthy garden is where are we getting the diversity that we need on the plate, right? And there we look at the food systems. And while we are very good as at the global level in terms of growing cereals and providing for everybody at a very low cost, somewhat so for oils. We struggle with proteins, and therefore there are all these high-tech areas of proteins, from mycelial proteins to microbial proteins to cultured meats to alternative proteins. And we also have a very good, actually a leading program in that. But all these actually reduce diversity in our food. So when we look at healthy gardens, we are talking about regenerative ecosystems that bring diversity on the plate. And specifically, our university focuses on forgotten foods, wild edibles, etc., and creating ecosystems for them and bringing them back on the table. Yeah, so that's kind of the big buckets of
Exactly.
research program. Yeah.
That's impressive. I've also heard you talk very uh, with great passion about the diversity of food on your plate. Would you
Yeah.
like to say another one or two lines? Because I don't think that young people think so much about, having diversity of food on their plate at every meal. So if you'd like to say a few lines, this might be a good time to do it.
Yeah. So, I mean, if you look at uh, the last 20, 30 years, especially at the industry, has always been looking for, everybody's looking for a superfood, right?
Mhm.
That's the buzzword. What is a superfood? Can I get a superfood? No, this is a superfood. Let me eat it daily, right? Etc. If you start looking at literature, I mean, both modern as well as traditional, such as Ayurveda, etc., they seem to be suggesting they don't talk about superfoods, right? They talk about diversity on the plate, right? And this area of microbiome has actually given a very interesting twist to this diversity on the plate, because what we realize, all the last 22 years, 23 years of microbiome research, everybody seems to agree on one thing, right? Which is that the number of different species of bacteria, of microbes that populate one's gut are an indicator. If they are higher number of species, so the diversity of species is an indicator of health, right? So the question now is, how do I harbor more number of species in my gut? Well, to harbor more number of species, you need to eat diversity, right? And so how do you get diversity? Therefore, there needs to be diversity on the plate. But how do you get diversity on the plate? You require diverse ecosystems, right? And so it connects the environment, the ecosystem with the plate, right? With the gut, and then with my health, right? And that's a very beautiful connection, right? In fact, people are now talking about that every week we should make sure that we are eating 30 different plants, right?
Wow. Okay.
So that's one diversity. If you look at Ayurveda diversity, Ayurveda would talk, so this is phylogenetic diversity, right? 30 different species. Ayurveda has another very interesting twist on diversity. It says that every meal should have all the six rasas, right? The rasa is the in-mouth experience, right? As opposed to taste, which is may not be the right definition. And there are six in-mouth experiences that Ayurveda describes. There is sweet, there is sour, there is salt, there is bitter, there is pungent, and there is astringent, right? These are the six in-mouth experiences. And it says that we should have foods which have these six in-mouth experiences uh, on every plate, right? At every, and that's a very good rule to design dishes. Once you have that rule for diversity, and then you can start plating. So every food in our database, right, besides their chemistry composition, we have about 184 parameters of chemistry, like the amino acids, the minerals, the polyphenols, the fatty acids, etc. Besides that, we have the rasa for each food, right? The primary and the secondary for each food listed there, along with many other Ayurvedic properties. So that's something on diversity. And today, more and more papers coming out that people who would eat more diverse diets, right, are healthier. And even more so, it's more critical uh, in developing and emerging, right, world, where we've seen that malnutrition is lower where people have a diverse diet, and wherever the diversity has reduced due to various well-intentioned actions but leading to diversity loss, such as the public distribution system, for example, right? Very well-intentioned, but reduces diversity, right? And therefore has to be complemented with another policy which makes sure there's diversity on the plate, right? So those kind of researches are happening around the world, and that evidence is building that besides calorie sufficiency, besides macronutrient and micronutrient sufficiency, we need to put diversity of nutrients on the plate, because we do not understand, no one food can deliver all the nutritional needs. And secondly, the nutritional needs that we understand are probably a fraction of what our body requires, right?
Great.
Yeah.
Thank you for that. Let's jump into education. So, tell us a bit about the, food-related education programs that you are doing. I know that you have a couple of master's degrees, and then also the BSc Food Processing and Technology. So, give us an overview, and then I'd like to get into some details of the BSc Food Processing.
Right. So yeah. So we started our education program. Of course, we had a PhD program that we've been running for the last, whenever, since the university was founded, it's about 10, 12 years, and food PhDs over the last 7 years or so. But our first degree program was the master's by MSc by research in what we called as food science, processing, and innovation, right? That innovation word was key because we wanted students to understand the whole journey of taking an idea, a concept, and taking it all the way up to an innovation, right? And what all is required through that journey, right from the basics. What is food labeling? How do I label a food, right? Nothing is sold on the shops without a label. So what does labeling mean? What is the food safety? What are the regulations and the policies, right? And then what are the processing techniques, etc.? What are the cutting edge technologies which are there? What's the chemistry of food? What's the biology of food? So putting all these things together, but we have some very, very unique courses and workshops that are part of this, which are typically not there in many food programs. I mentioned the food systems thinking, so that's a course. The design thinking for foods, that's a course. The integrative nutrition, that's a course. Food and microbiome, that's a course. Also, interesting things like food photography, food videography, right?
Right.
The food and wild edibles, how to create wild micro ecosystems or food forests, right, is the course. Food metabolomics. So these are things which are not there. You will not find these kind of courses in many places, right? To be able to teach this kind of courses, we have 15 laboratories and pilot plants
Mhm.
uh, which service these courses, right?
Mhm.
And the kind of instruments and equipments that our master student are able to handle personally, right?
Mhm.
Students in most nutrition programs will not be able to even see those, let alone handle those, right?
Mhm.
Those instruments, like a twin screw extruder. I think in a university setup, a handful of universities in the world have a twin screw extruder, right, at a pilot scale to work with, right? Like a dry fractionation setup, right, to be able to separate, let us say, the proteins from the starch components without adding water or alkali or anything, just by using simple physics. Yeah.
Mhm.
Uh, uh, I think no other university in India has it, and probably only 4 or 5 in the world may have it, right?
Right.
So we have these kind of things which are very, very unique, right? And it's not just they are unique, but students actually operate these machines themselves when they're running their projects, right? So that's very unique as well, right? So that's the MSc by research. And the research part is because 60% of the course is experiential and project oriented, right? So that they actually learn, we make sure that they are mastering at least 5 cutting edge analytical skills and 5 cutting edge processing skills, unit operations in servicing their project, right?
Mhm.
So that when they go out, besides what all the basics that they need to know about food preservation, food safety, food microbiology, etc., uh, they know these, and the knowledge that they know can then easily be applied to new situations and new instruments, new equipment. So that's the MSc. Uh, the the BSc program then came out of the MSc. Once we had these laboratories established, once we had enough projects, we had converted those projects into materials and texts that are required at the undergraduate level, at an introductory level.
Mhm.
We started the BSc program. So the BSc program is again a experiential program, right? Again, looks at what are the needs of the industry, both small and big, right? So right from farmer producer organizations, self-help groups, all the way to big food, right? What are the needs, and what are the needs of the country, right? A lot of our program begins by looking at what is the national family health survey number 4 and 5 saying, because that is telling us what the country needs, right? So our programs are really stemming from what the needs of the world are, the needs of the country are, the needs of industry are,
Mhm.
and students get equipped with that kind of thinking very, very early on, right at the undergraduate level. So it is
Mhm.
not about read this chapter and solve this problem, but
Mhm.
students learn to define problems and solve problems, right? So critical thinking. Yeah. So
Great, thanks. So, students often, when they're making choices about which courses to study, there are
yeah.
two things there that, am I eligible, and then what is the prospect for me when I finish my studies.
Yeah.
So what would you advise students? What kind of interest should they have if they want to opt for this BSc Food Processing, and also what is likely to be their prospects after they complete the course?
Yeah. So let me first say about eligibility, right?
Mhm,
And then come on to the other two aspects, no? What they study uh, and their prospects, right? So the first is the eligibility part. At our university, in our program, we look at one criteria for eligibility, which is interest, student interest and motivation. They have to be motivated because you can take a horse to the water, but you cannot make them drink, right?
right.
So our only discussion interview with them is that they have passed an undergraduate degree. We're not looking at their marks and saying are they top of the class, etc. And can they convince us that they are interested in this discipline? We'll take care of any bridge course that is required at any right. So we are not expecting. We will take whatever. If you have the interest, you have the inclination, we are there to address, right? So that's our eligibility part, right? Science education certainly helps, right?
Mhm,
The science education with some maths certainly helps. But if it is missing, we will do a bridge course and help you, right? We'll
right.
handhold you. So we don't go for very big classes. We go for a class size where we can handhold every person, right?
Mhm,
And give them a bespoke education as per their need. Almost it's a mix of, you could say, there are two education model systems in the world, right? There is the Oxbridge model system, and then there is the MIT Harvard model system, right? The MIT Harvard is there's a classroom, there are students in there, and I'm delivering a lecture. Whereas the Oxbridge original model system was that, hey, it's a one-on-one mentorship, right? Almost, right? And so we are a mix of both, somewhere in between. So we are bespoke in that sense, right? Hand holding. So that's the eligibility part,
mhm,
right? Second, I think is I'll answer in a broader term as to uh, why should somebody look at BSc in foods, right? And then what should they look for in a place where, because there are a number of choices to do such a degree. And third, why TDU? So I think why I have mentioned as to a degree in foods is a good idea, because some of the most exciting times where food, people are looking at food to solve big problems, right?
mhm,
Global problems. And there's cutting edge science, which brings together the whole area of genetics, epigenetics, microbiome, machine learning, artificial intelligence, omics, right? Sciences all together into, right? So it's a very different field now compared to what it should be. And therefore, the students need to be looking for, when they look at curriculum of food programs around the world,
mhm,
are there courses, right, which are these kind of courses there, or is it still the same courses that were there 20 years ago? Because food, right, sciences, food studies has changed, right? So
mhm,
find places which are in tune with the changes and are delivering courses. Are there courses on food systems? Are there courses on design thinking on food? Are there courses on food and microbiome, right, and such things? So find those places in the world,
mhm,
right? Find places where faculty, there's diverse faculty. So faculty has both academic experience but industry experience and outreach experience, right? Because that enriches the program. It's no longer about this is the textbook, and therefore, right, faculty understands the textbook, given a textbook, and then delivers from them. Faculty need to have their own experience from the real world. So find, do faculty have that experience, right? Third is, do they have the infrastructure, the
mhm,
laboratories and the pilot plants, and will I actually get to use these, right?
mhm,
Or are they just showpieces somewhere where you require a lot of permission to be able to use it, which basically means that you'll very limited time, right? And therefore, what is the class size? Do you have access to them? So those are some things I will advise students to look at. Number one, why food? And it's a very interesting option amongst all the other options. Secondly, right, what to look for when they're making a decision. And I'm happy to say that TDU and its board and its management has been investing in all these things, the infrastructure, the faculty, which is a very good of mix of science and engineering and chemistry, both academic
Mhm.
background and industry background, people working together, and the labs and the pilot plants with cutting edge equipment, and the guts and the will to actually expose students to those and give students access to those, knowing that there are challenges, right?
Mhm.
That things breakdowns will happen, right? And various things, but the university is putting students first, right? And so that kind of, so find that I'm happy that TDU does that. This is one place, and I hope many other places in the world and in India will do that because it's required. Right? And
Got it.
lastly,
So,
what are the prospects, right?
yeah.
So I
Mhm.
think prospects are many, beginning from looking at jobs, right? TDU certainly has a very good connect with the industry. While we do not have a formal job placement program, but the industry connect for TDU is exemplar, right? I think nearly about 100 companies connected with us through the workshops that we deliver, through the courses that we deliver, through the symposiums that we hold, through the
Mhm.
projects we run for industry. So there's a
Mhm.
good connect across India. And that connection is open to serious students. So that's the industry part. Then, of course, there is that students can go for higher education, masters,
Mhm.
if they wish to. Right, and so the whole, I mean, they can go into then allied areas as well. Food is
Mhm.
a starting point, and they can chart out allied areas as well, right? If their interest is there, if they want to get into deep science and pick up biology as an area, post that, because food and biology is a very important area, and there are a lot of opportunities opening in the world in that area. So yeah, uh,
Thank you for that. I mean, you already touched on various aspects of the curriculum, but I wanted you to expand it a little bit more to kind of indicate. You mentioned that you everything from food labeling to food photography is involved. But I wanted you to kind of talk a bit more about our approach to curriculum in terms of core and electives, and and also sort of highlight for our listeners, some of the very interesting programs, things, innovative things that your students already here are doing,
yeah,
completely unique stuff, like something you mentioned about mushroom and this other fig and so on. So if you could
yeah.
just talk about that a little bit.
Yeah. So yeah, how is the curriculum constructed, right? So the curriculum is constructed. There are core and electives, right? And when we look at core, there are some core, which is, for example, the university core courses, right? University transdisciplinarity is a big, so that's a core subject. That what does transdisciplinarity mean? We feel that's an important concept, right? Then there are core like maths for food scientists, right? To be able to calculate what's the percentage of protein, what is the RDA percent that you have, right, to be able to write variables. Then there are the core courses which are getting people industry ready, right, which we call as food safety, food regulations and policy, right, food quality assurance, right. These are activities that you have to do when you join an industry, right? So they're industry ready. We make everybody industry ready, right? From writing labels to do this, right? Uh, and we have industry people teaching some of these courses, right? So that it's practical, right? Uh, and then we have the what we call as the core food uh, courses, the food chemistry, what is there in food, food microbiology, right, and food unit operations, right. So they are a must-have courses, and some of these courses are courses that where we have made sure the content is aligned to, for example, with FIXI, right? We have a MOU with FIXI, which is the Sector Skill Development Corporation of India, and so the content is therefore a content which runs across, and students who enroll for a bachelor's degree have the opportunity to get a BVOC certificate along with the BSc certificate if they satisfy all the requirements of the vocational training as well. And that certificate comes not just from TDU but also from FIXI as a separate, right? So that's that's an arrangement that I think you were instrumental in putting through, Leena, right? And then, of course, there are a number of electives depending on what the student interests are, right? There are about 20 or so electives that we run, right from protein processing, starch processing, uh, uh, dairy, right? Functionalizing dairy foods, etc. So very mushroom lab is there, right? You mentioned so. Fermentation lab is there. So those are very interesting courses depending on what the students' interests are, and they are offered to a BSc as well. And then the BScs we try, we don't guarantee, but we do try and see if they are interested to give them industry apprenticeships, right? As one semester, right? So they get to work in an industry, and if we cannot give them, provide them, or connect them, then we can give them apprenticeship in our pilot plants, right? So they get to actually work with equipment and instruments, right? So that's the BSc program. And then the program you mentioned, some of the interesting thing. I think one of the key areas where probably we are number one, not probably, I think we are number one in India. Nobody does a rating of such areas. But if you look at protein processing, right, converting protein into foods, and we're number one in India. Uh, uh, I mentioned a twin screw extruder. An equipment is required to take plant proteins and convert them into textured, structured proteins, whether they be dal analogs or paneer analogs, or textured vegetable proteins, or high moisture meat analogs, etc. A variety of things, right? And and we are at the cutting edge of that work. And so there's a whole uh, uh, course which is developed, which the undergraduates at the BSc get to experience that unique course. Mushroom lab is another, where we take all the way from uh, why is mushroom important, right? Not just, as I said, from a human health perspective, because it has a very good 20-30% protein in there and a very good profile of amino acids, but also that mushrooms is probably the only uh, living species on planet Earth which can convert straw, which is a waste material that no animal can use, but it can dig out nutrients from things like straws and convert them into edible proteins, right? So there is a environmental and ecological. India produces 300 billion kgs of grains, right? We have a 8 billion population. Sorry, we have a 1.4 billion population, right? And we produce 300 billion kgs of grain, right, every year. Cereals, pulses, millets, etc. We also produce, along with this grain, 300 billion kgs of straw, right? And that 300 billion kgs of straw has nitrogen in it, has phosphorus in it, has potassium in it, has minerals in it. And the only living form which can tap these things out there, because no other life form can get it out there. I can't eat straw, a cow can't eat straw, a goat can't eat straw, right? The fungus can, mushrooms can, right? And they can convert into foods which are safe for us and
Right.
nutritious for us, right? So you're tackling human nutrition, resource constraint, you're tackling multiple things, right? And those are the kind of ideas when students work on. They're not just learning how do I grow mushrooms, or how do I cook mushrooms, or how to create a mushroom-based processed mushrooms, right? They're learning why we are doing this, right?
Mhm.
And that helps, right? And that thinking helps and sets apart our bachelor students from the next students. Millets, for example, right? There are millet processing labs everywhere, right? In India, right? There was in 3 years ago we had the International Year of Millets, uh, but millets have anti-nutritional factors in there, right? And therefore, daily consumption of millets is a challenge, right?
Mhm.
We teach how do you get rid of. We don't just teach about what is the nutritious in there. We teach about how do we get rid of anti-nutritional factors which are there in foods, so that you could have an extra serving of that on your plate, right? We also look at what are the challenges, right, that people have when they want to use, say, millets in their kitchen. Millets don't make dough very easily, right? Like wheat dough, right? Why is wheat popular? Makes a dough very easily. Millet doesn't do that. It doesn't have the sheetability, it doesn't have the extensibility. So
Mhm.
our process, we teach about how do you get these, what are the consumer facing attributes or functionalities which are required in food ingredients, and how do you get that through our food processing, right, steps. And a lot of these insights are coming from our traditional knowledge, right? And how do we make it contemporary, right, is the key, right? So that's how we explain students where to look for this knowledge and answers, right, as a starting point. How do you ideate from there? How do you convert them to prototypes to test, right? Convert a concept into a prototype. And how do you take a prototype forward? And what are the claims that you will write on it? What are the functionalities that you want to address to convert into a product? Right? And that's what the 3-year BSc program is. Yeah.
So you've been speaking very close to entrepreneurship. So tell me a bit about some of the, innovation and entrepreneurship work that the students are doing and your researchers are doing, and how does TDU see your group see that activity growing actually, and that students can participate in actually.
Yeah. So we encourage students to be entrepreneurs, right? In their thinking at least, right? Well, it's not that we are asking them to become entrepreneurs, but we feel that no matter what job that we pursue in our life, we need to have entrepreneurial thinking, right? And therefore we teach that, and therefore uh, a lot of the courses are designed, right, to get people on that journey of what does entrepreneurship is, from inception and ideation all the way to an innovation and everything in between, right?
Mhm. Mhm.
And so the students are encouraged to pick up a project from from their first semester, and ideally from their first week onwards, start thinking about what they will work on.
Mhm.
And we are hoping that by the time they finish their 2 years, therefore, they have taken that idea forward, and if they so desire, they can actually take that idea that they have worked on for 2 years and create a startup if they want to, right, with
Mhm.
it. So that is the idea for us, that it is not about am I employable
Mhm.
uh, for someone, or do I pursue a higher degree. If I feel that I should create my own, right, startup, then yeah, be an entrepreneur. Then
Mhm.
a lot of the thinking part has already been done, right? And then it is about looking for funds, etc. And we'll help. And what they have here is a network. I mean, one, the infrastructure that even if they step out, they're related to us, right, as an alumni, and therefore they have the infrastructure available that they will need to go on this entrepreneurship journey, right? And yeah, so
Thanks. I should probably have asked another question first before asking about entrepreneurship, and that is about the relationship with industry that you mentioned. I mean, having connects to 100 industry groups is not a trivial number at all. That's very large. So
mm,
obviously there are jobs too, but tell us a bit more about just some example, just a sense of what you are doing with all these industry. Because the next question I want to ask you is, how is the food industry evolving in the future? But I'll ask that again. Right now, you just tell me about what you are doing with the 100 odd relationships that you already have.
yeah. So out of the 100 or so, I think, so there are multiple different levels of interaction, right? With a few of them, we have project interactions, right? Which is the industry comes with a very specific project, right, in mind. Uh, and we have the capabilities to work on it and try and find a solution. And so we work closely on what we call as sponsored projects, right? Therefore, and we have a number of companies, small and big, that we have worked with, right, on such projects. You name the big companies, the big five companies. You look at uh, companies around the unicorns, etc. of recent years, Irish years, etc. Right, we worked with, right, uh, most of the companies that any student would think of, right. And so that's one level of interaction. We're actually working on problems, statements coming from the universe, from the company. The second is, and that's something we've just started, right, doing, is that over the last 6 years or so, we have about 25 or so ideas that are almost industry ready that we've been working on, and we have IP on them, and we have industry readiness, and we have been showing these to various industries in show and tell sessions, right?
Mhm.
And so there is interest. So there are industries that are coming forward and saying, hey, this particular idea is something I would like to work with you and see if I can take it forward. And so we have MOUs with some industries
Mhm.
on those, right? The third level is where we understand a certain technology well enough, right? And we'll run workshops, right, and webinars in that space. And so the industry participants come specifically, right, for understanding a particular aspect like protein extrusion or flour extrusion or rheology, food, etc. And we run workshops, right, or food and microbiome, right, or
Mhm.
fermentation, kombucha uh, making, right, etc. We run workshops on specific areas, and industry come and we pass on the technology, right, to them. And yeah, so those are the three big areas. Besides industry, we also are connected with many NGOs and outreach organizations, right?
Mhm.
One of our partners, for example, is one of the things we work on is midday meals, right? And how do we put enough proteins on midday meals, enough nutritious food on midday meals? We're working with one of India's biggest midday meal providers, right? Akshay Patra, for example, right?
Mhm.
In midday meals. And our students, right? The bachelor students, BSc, MSc, we take them on these field visits, right? I mean, for example, all of our students went on a field visit to see one of the Akshay Patra's kitchens, right?
Mhm.
Where
Mhm.
midday meals are made and how they're delivered, right? It's important to understand how these things are executed. So we don't
Mhm.
just take them on industrial visits where, oh, this is how an industry runs, and you look at big reactors and tanks and how they are laid out, which are equally important.
Mhm.
But also these kind of operations, right? Big kitchen operations and other things, because you require food scientists, food technologists to be able to be there to deliver quality food at every single plate, right,
Mm.
of India.
Yeah. Thank you for that. No discussion on food would be complete if we didn't talk about recipes and, the Indian approach to cooking and so on. So at the beginning of the program, you mentioned that, the principles that Ayurveda's principles that you use about, bringing all the rasas into every meal. Tell us a bit more about all the, you run a YouTube channel on recipes, I believe. So, tell us a bit more about all of that.
Yeah, so I think what we realized early on, I mean, I mentioned the database that we curated, right? One of a kind database. A big part of the database is recipes, right?
Right.
That we curated from classical texts. There's 3,000 years of classical texts. So we have very interesting recipes, etc., from classical texts, right?
Yeah.
And now databases are, in a sense, dead bases, right? Because, okay, so it's there, especially when it comes to food, because the real test of a food is when you taste it, right? When you see it, you touch it, you taste it, right? You hear it, right, etc. So we felt that what we require
Mhm.
to bring alive this database and make it useful is to actually create a kitchen, right?
Mhm.
And so the university invested a big chunk of money, and thanks to donors, right, where we set up a state-of-the-art research kitchen, right? And our students, both BSc, MSc, they spend their time in the kitchen, right?
Kitchen.
So there is a great library we have, and then there's a great kitchen we have, and then
Uh-huh.
there is a great food forest we have.
Yeah.
And then there are great pilot plants and labs, right? So this kitchen and food forest are very unique facilities that are not there in most programs. And the state of the research kitchen we have
Yeah.
is, people have walked in and said this is better than the research kitchens of Michelin star restaurants in terms of the kind of things that are there, right? That so just like dream of having such equipment and tools available to them to be able to construct and deconstruct food and do all sorts of molecular gastronomy. And it's up to everyone's, the students' imagination. What do they want to create and prototype? It's our rapid prototyping center, right?
Mhm.
Just like a electronics laboratory would have, or a mechanical engineering. This is the food science equivalent for a rapid prototyping center, right?
Right.
And that allows us to experience the recipes. We created it to look at the recipes in our database and cook them, right?
Mhm.
But it is a facility that our every student of ours uses. They get a license to work
Mhm.
uh, after a certain training to be in the kitchen, because kitchen is of course a dangerous place, right? You have sharp objects, you have moving objects, you have fire, right? You have all sorts of things, right? And so safety first, right? And that's important. But students get that very early on, right?
Mhm.
And, uh, and hygiene, of course, right? And those things, when they work in the kitchen, they are not just learning. I mean, we say food safety, food hygiene, those are courses, but you're applying them in the kitchen. So you're learning them
Mhm.
first on, and they help each other, right? When they see things not happening, somebody is so they become each other's mentor, right? In some sense, right? And so that's a unique facility, the only one of its kind, probably anywhere in the world, in a non-culinary science university, right? Department,
Right.
right?
Right.
But I'm told that even culinary science departments do not have this kind of a setup, right? Uh, so that is a big part of our
Mhm.
recipes.
Mhm.
Recipes come from students. Every year, we in one of our courses, food systems course, the final exam of that particular course is actually a cookout,
I
right?
see.
And the
Uh,
mandate given to them is cook a menu, right? For, imagine you are in 2050,
yeah.
right? And so cook a menu for 2050. And your defense, just like master chef, they come out, it's beautifully plated, etc. But when you they talk about the dish, they are talking about the dish from why do they want these ingredients there on the plate, and why have they cooked it in this way. And they have to
Mhm.
articulate and defend the dishes from a nutritional perspective, from an environment perspective, from a livelihood perspective,
Mhm.
etc. So that's the kind of experience that students get right here. Yeah.
So that's wonderful. I was just noticing one thing, that you have talked about wild edibles and foraging foods and things. These are not some things, the words that students hear very often. Would you like to elaborate a little bit on what those that is, and the principles behind it, and how you are integrating that into the research and the teaching that you do?
Yeah. So one of our emphasis when we talk about food and health, right, and all the three dimensions of health, uh, uh, as we said, uh, a lot of our last 100 years of food history, food innovation has resulted in loss of diversity on the plate, right?
Mhm.
To be able to address food security, etc., we looked at industrialization of food to bring the cost down. And that has inadvertently resulted in loss of diversity, which we are now beginning to understand is equally important, right?
Mhm.
So how do you pair the two, right? And the research that we've been doing is that can forgotten foods and wild edibles, edibles that are not cultivated but gathered, right,
Mhm.
can be there on every plate every day, right?
Mhm.
We don't need, these are not the calorie rich. We don't need bulk of them, right? It is, can I have this as a garnish? Can I have this a small sprinkle as a podi or something right in there, or two leaves of them? That's all that is required. That's all. They
Mhm.
bring diversity on the plate. So
Mhm.
we are looking at uh, wild edibles, forgotten foods, right? And a lot of them come from our database. So
Mhm.
now we have a parallel database where anybody in India, if they give us a GPS location, we'll be able to tell them 50 wild edibles or forgot, right? That are
Wow.
local to them,
Yeah.
right? We'll be able to tell them a package of practices that how to take these, source these seeds, seedlings, plantlets, and create a food forest. If they send us a picture, we'll actually put a grid of their land as small as 3,000 square foot, right? And tell how many number of plants of each species to plant where, so that
Mhm.
eventually it becomes like a forest. There's a
Mhm.
difference between a forest and a farm or a
Mhm.
garden. Right? A garden requires a mali, right?
Mhm.
And it's two-dimensional. A forest is three-dimensional. There are
Mhm.
multiple layers, right? From understory to canopy layer, right? Or from the rhizome layer to rhizosphere to the canopy layer. And uh, the nature takes care. Nature is the mali, right?
Mhm.
So we are developing this expertise to create micro food forests. The food forest in our TDU, which students get to interact with and work in, is 4,000 square foot, has 75 species of wild edibles growing there, right?
Wow.
And there are
Mm.
recipes for all of them, right? So yeah.
That's stunning, actually. Yeah. Is there anything else that you would like to share with students about why TDU's food program is so special, actually? I think I've
No,
asked you many things, but
yeah.
I'd like you to. Yeah.
No, as I said, what sets the TDU program apart is that it connects the future with the past, right, with the tradition, right, and presents it as a continuum, which is what we call as an integrative
Mhm.
food and nutrition science, right, program. It connects what we learn in the lab with global problems, whether you are at a United Nations meeting or a government. They are talking about today the environment, livelihoods, and our own health, and it's connecting that and presenting these problems. So you're working on real world problems. There
Mhm.
is infrastructure. The content has been created through the experience of the faculty, right? Who are working in these areas on projects. There are faculty which is a good mix of industry and academics. It's a very open learning environment.
Mhm.
Uh, there is hand holding, batch sizes are small. Uh, we uh, we look at each student uh, as a special student with and design curriculum for them, right?
Mhm.
So
Mhm.
I think those are things to look at. It's a curriculum for the present and for the future, right? Which is why it's called Food Futures Program. Right.
Yeah. Thank you. That's it's been very inspiring listening to you. But I if, with your permission, I'd like to ask you a last question. You mentioned that you do a lot of outreach, and I believe some of that outreach is in the areas like anemia and so on. Do students are students related to that? I mean, connected to that kind of work, or are there other areas in which you do outreach?
Yes, I mean
Tell us a bit
students can.
about the outreach program. Yeah.
Right. So students can. So we do outreach programs. Anemia is a big outreach program. It's probably India's number one public health challenge, right? With nearly 50%, more than 50% of India's population being anemic at some stage in their life, not. And it has very severe consequences on health, long-term health, as well as on livelihoods, productivity of an individual, the family income, etc. So it's something which I feel that actually every university in India should have a department for anemia itself, right? It's such a massive challenge that we need to address. And we do run outreach programs, and we have a very special outreach program which we call as a 5-tier outreach program, which includes sensitization about understanding of what anemia is, what eating right is, what should I eat more of, and how should I cook if I want to improve my hemoglobin level. What are the kind of functional foods that I can make at home, and also what kind of entrepreneurship models to be able to do that at scale. And we run one such program in the Nilgiris. We've been running it for 2-3 years now, where we work with tribals, with rural communities on these various aspects. And students get to work on various aspects of it. If they're interested in field work, they get to do the field work. And if they're interested to craft solutions in the lab, whether on personalized nutrition or eating right practices or designing functional foods with respect to anemia or some of the other public health challenges for which we have outreach programs, then they get to design those, and they have the uh, I think the happiness of seeing that their work is actually connected to the front end, right? It is not something that they are working on. All their projects, we kind of take it forward and see how we can fit them into our outreach program. So they're not working on projects which is I write a thesis and that's done. Those projects will stay alive, and that gives a very different kind of satisfaction to students. Yeah.
Fabulous. Thank you so much for your time, Gurmeet. It's been wonderful listening to you, and I hope the listeners enjoyed it too. Thank you.
Thank you so much, Leena, and thanks for the opportunity to talk about the program. Right?
We loved listening to you. It was fantastic, actually. And I mean, I know some bits of it, but this holistic laying out of the scope of the thinking around the Food Futures program has been fabulous. Thank you.
Thank you so much. Bye-bye.